Hello guys, welcome back to Analyst Adda. So these series are going on these solid principles. Okay, so we have already discussed the L solid part of L is list scope substitution principle in the previous video. So today's class is the ISP interface segregation principles. This SOLI, right? I means interface segregation principle. Okay, so this is our today's class. We will discuss what interface segregation says. Okay, so interface segregation principle says don't force a class to implement interfaces if it doesn't use. Okay, or we can say the client should not force to depends upon interfaces that they do not use. Let me take an example. For suppose when we for example when we create the interfaces, correct, interfaces with too many methods, right? So we end up forcing implementing classes to write dummy code for methods they don't need, right? Or another way, if the class is not provide the dummy implementation, we need to make that class as an abstract class, but next level of subclasses will make to force to provide the implementation. This is the problem we face in interfaces. So the solution of this problem is follow the ISP interface segregation principle. Instead of creating the big interfaces, break it down into a smaller interfaces, which will more specific interfaces, and whatever interfaces we need, we can take it, we can implement in that particular classes. Okay, so let us take any examples. It's a coding examples. Okay, so okay, first I'm taking the example without ISP. Okay, without following the rule of ISP. Suppose it's a interface. I'm creating one interface workable. Okay, this interface. Okay, okay, interface workable. Okay, I'm creating methods here. Okay, work, and second is eat. Understood? Okay, I create one interface workable, and inside the workable interface I create the work and eat two methods. Okay, I'm just creating a class here, row. Okay, that is implements workable. Okay, so here we need to provide the implementation for both uh, methods, which is declared in the above interfaces which we are implementing here. Okay, but suppose robot is a class, we need the only work void method. We don't want to use this void eat, because robot is not eating, right? Eating habit, it's provide the work only. So okay, implementing an interfaces and remove for this one, or we can say okay, so this is robot and I'm providing the passing the message robot eating, right? But sorry, working, but robot is not eating, correct? So here we need to throw the error message, supported operation exception not eating, right? If I robot dot eat and robot dot work, these two methods. Okay, I'm running the Java application, and you can see here, what does it see? It says robot is not eating. But after this we provide this work, so we are not getting the output from here this. But suppose this one, then we will get the output, because before getting the exception, runtime exception, we can get any of the positive output. Okay, but if in that particular lines if we are facing any error, after that we can't get output. Okay, positive outputs. So robot working, but after that robot eating, so we are getting the exceptions, unsupported operation exception, robot is not eating. The robot is not eating we provide here, right? Whatever message we are providing here, we will get here. But this is not the this is error, this is we are not getting the correct output here. So the first solution is, this is the problem we are most of the time we face in interfaces. So we need to, if suppose if we don't want to provide the implementation for the eat, then we need to create the abstract class here. Once we make abstract class, then we need to provide the, then we can suppose if we provide make any class as an abstract class, then we cannot instantiate the type robot, right? Robot, we cannot, when we cannot create any object for the abstract class. So this is wrong here. Okay, and this is also wrong here. Okay, and so we need to create the another class, suppose the human class. Okay, class and implements robot. Then sorry, extend, this is not interface, extend. And here you can see we need to provide the unimplemented methods, whatever rest of methods he left in the robot, we need to provide his making forcing, we need to provide the unimplemented method implementation, right? If we suppose add implemented method, it provides only one implemented method, that is eat. So we need to provide the here the human working, sorry, eating, this is eating, human eating. So now I can get the output from here. but with this class, not with this class, the robot class, we can't create the object. Workable dot eat and workable dot work, right? Again start the program, and you can see here we will get the output. Now we are getting the correct output: human eating, right, and the robot working, right? Suppose if we want to provide the work for the humans, right, then we need to create we need to implement the workable interface here, right, and we can override these methods. So at that time we cannot instantiate the, we cannot get the output from the robot class. Okay, we can get the output only from the human class. So this is a problem we also face in the interface. So instead of using I'm not saying we cannot use the interface of always time we need to create these small interfaces, but based on the requirement, according to requirement, we need to create the interfaces based on the requirement. So here is the requirement: we need to create the small interfaces. Suppose for example, if we provide the interfaces for work and the eat, different, right? Suppose interfaces work, I'm removing here, this is workable, I'm providing only one method here, and interface eatable, well, okay, and eat method, okay. So I break down the whole interface into the two interfaces, okay. First one is workable, second one is eatable, and I'm removing here the abstract class, okay. And here I need only the workable interfaces, so there is the problem will not face is at this time. And here I need the workable interfaces, implements, or eatable interfaces. Both interfaces I require for the human. I need to implement the work. So here the human working is saying duplicate interface here. Cable. Okay. This is eatable. Workable and eatable, right? This is human and everything here. Human dot work. So according to this, now human dot eat. So I'm getting the both output from here. I need to create the class for the out, output for the robot. Now I can create the object for robot, right? Robot having only one method, right? Work, right? Now start the application again. You can see here human working, human eating, and robot eating. Robot have only one method, so robot working, but human have the two methods, right? You can see here eat and work, so human working, eat, or human eating. So this is the problem we can solve in this way. Okay, here I am following the ISP, interface segregation principle here, and so that's why we solve this problem based on and follow the principles of ISP, right? I think you can understand this way, okay, how to solve this problem if you face these types of problem, and how to follow the ISP principles. Okay, so in this class, that is okay. I hope you understood this thing and this way how to solve this problem. Okay, thank you, bye.